in person in, in 255 Psych Student Union, and for those of you who are joining us online via Zoom. Our office has been proud to co-sponsor this series of presentations with the university's Office for Research and Sponsored Programs and the Sustainability Council's Scholarly and Creative Activities Committee. We are now in the 9th year of this series, and this semester in particular, we have not 12 as we usually do, but 13 presentations. If you have not attended before, please know that every Wednesday at this time, except for Thanksgiving week, you can come and hear one of our amazing faculty or a staff person or an invited guest or students who will be speaking in our very last presentation of the semester. So please join us. There are copies of the program here at the front if you would like to take a print copy, and for those of you online, you can find a PDF copy on the Office of Sustainability's website. Now, without further ado, I'd like to hand the podium over to our speaker this week, Professor Daria Nikitina.
Well, thank you, Bradley. Thank you very much for showing up here, and those of you who are joining on Zoom. More people are joining on Zoom, so that's a very exciting opportunity for me. A little bit of the background. I am a professor of geology here at Westchester University. I am a geomorphologist, and this is a discipline of geology which studies the landscapes. So that studies everything what happens at the surface. And of course, humans are part of the landscape, but it also has the physical part of that. So it's very much connected to geology. Why do we have certain landscapes around us? And everything what basically happens in the atmosphere and at the surface of the Earth impact and influence these landscapes. So that's kind of a holistic discipline. So it requires some good knowledge of geology, but also climatology, meteorology, so kind of a geography aspect of that, and human impact on these landscapes. So I know I probably will be preaching to the crowd here, explaining why do we concern about the changes which we're experiencing around us, and those changes are related to climate change. So the science of the climate change. Okay. So tells us, so the instrumental observations tells us that we are warming, and we're warming really, really rapidly. And pretty much every year we hear that we just lived through one of the hottest year on record, and then the next one comes, and then we're in the next hottest year on record, and so on and so forth. And so far we see the consecutive record of years which were declared the hottest year on record. And if you wonder about the year 2024, sure enough, it was officially the hottest year on record. So basically, the climate change is one of the greatest challenges of our time. And so this record goes back to 140 years, where we compare these changes. And so the trend just shows us that we are acceleratingly warming up. So far, we have warmed the planet by about 1 degree Celsius, which is about 1.5 degrees of the Fahrenheit. So this is so-called hockey stick record, which was reconstructed and presented by the climatologist, the US climatologist Michael Mann. So currently he is a professor at the University of Pennsylvania, but when he was working on this reconstruction, he was a professor of climatology and director of the Center of Climatology at Penn State University. So he used him and the broad team of colleagues used climatic proxy record, looking back into the climate, reconstructing the climate temperature, the air surface temperature. And so then they compare this reconstructed record using these proxies, and those proxies, tree rings, corals, of course, some historical records, so you name it. So the science is very well equipped now to reconstruct those climatic signals in the past. And using this proxy record, they were able to go about 1,000 years back. And when they were doing it around 1990, so that's was already clear that the thermometers, which were recording the temperatures going back to 1800s, show the consistent acceleration of this temperature. So when they compare that record, the proxy record, with the thermometer instrumental record and connected it, so it just looked like a hockey stick, showing that the temperature increase of the temperature is accelerating. So the zero here is the average temperature, average annual temperature between 1961 and 1990. So that's just, you really need some sort of a reference. So he presented that to the Congress and many other legislative bodies, and so was actually prosecuted. And so there is the whole story. By the way, by now he won all of the law courses with the government, and so the hockey stick is still here, and of course the science moved way further on. So this is the IPCC sixth assessment report, which was published back in 2021. So for those of you who are not familiar what the IPCC is, it's called International Panel on Climate Change. It is the international organization which involved climate scientists from all over the world. What they do for the matter of 4 years, so they routinely go through all scientific literature on climate change and make an assessment, not based on their own data, not based on their own research, but overall on the whole progress of the climate science during the 4-year period. And then they come up with an assessment. And of course, this assessment has a lot of graphs and scientific data. So, so here is the hockey stick record, and the troubling trend started around 1850. So here is the observational data in a little bit more detail of this instrumental record. And being a climate scientist, I don't quite believe I am, but so I do know some parts of that it is a very complex system, the Earth climate system, and it has multiple components which are all interacting. So the temperature is, which is the amount of solar radiation that Earth's surface received, is just one component of it. So it includes so many other elements like ocean currents, like ice, state of the ice and glaciers on Earth, ecosystem, water cycle, carbon cycle, nitrogen cycle, and many, many, many more. So if you took all of those natural factors in account and predict what should the Earth climate be doing, this climate system would be doing, it actually should be quite stable. So this is the model, the simulation of the all driving forces which may potentially change the global climate, and it stays pretty much the same, stable. So with certain fluctuations, and yet, so this is the science, and this is the factual science behind it, that we are warming up and accelerating. And so what is the possible cause of that? Again, looking at all of the natural factors, I'm not going to go into detail because it is a lecture on its own. One component of this climate system is carbon cycle. How much carbon is being released into the atmosphere, how much carbon is being absorbed by the photosynthesizing plants and ocean biota. So how much carbon is actually stored deep down in the Earth's interior in the form of rock formations, such as coal and some other formations such as oil and natural gas, which are all consist of carbon. And when you look at that carbon cycle, it turned out that the concentration of carbon-bearing gases, which is carbon dioxide and methane in the atmosphere, are not stable. So they are showing this accelerating trend. So, well, basically, what caused our climate change is the increased concentration of greenhouse gases, as we call them, because these gases has the ability to absorb the heat and keep it in the atmosphere very close to the Earth's surface. So, and that is not believed, but it is proven that this is the driving mechanism of the climate change or global warming, as we call it, which we are experiencing in our lifetime. All right, and I'm sure that all of you have some stories to share. For example, I grew up in Russia. I am from a very cold country, and I lived through a very long, very snowy winters with 5 months of snow and lots of fun activities in the snow and under sunny sky. And I still maintain home in Russia and still go there during vacation. And I see hardly any snow anymore in Russia. And as a matter of fact, it rains on Christmas or New Year's Eve, which is absolutely unprecedented. But it's been years where I would go for the whole Christmas break and see no snow whatsoever. So that's climate change for you, of course. And as I said, so you probably all have your own experience. Doesn't matter what your time span of your personal observations with climate change. All right, so why do we care? So there are actually many factors. So there is increased temperature, heat waves, which we're experiencing again over and over, prolonged droughts, very extreme weather conditions. So we either have unexpected winter storms, which we never experienced before, or we have some exceptionally intense hurricane season and experiencing some lots of precipitation and winds associated with that. So the wildfires is also kind of become one of the things which is in the news all the time. And if you are interested or following what happens in our polar regions, where the big ice sheets are still in existence in Greenland and in Antarctic, so they are under the threat of the climate change and collapsing, melting, and receding. So again, so these are kind of going around of different type of environments or landscapes, if you wish. So currently, I teach a graduate level class in geomorphology. Again, so this is studying the land surface and processes and the landscape. So this is just a brainstorming, so it is a graduate level class, and we talked about, so all of the evidences of climate change. Of course, it is the increased temperature, but also there is an intense precipitation changes. So they became longer and more volume of water start coming from some of our storms. So there are places around the globe where the snow, as I mentioned, Moscow, for example, Russia, changing to more rain. Antarctic, which me and my husband visited once together, and I keep going to Antarctic for some research and professional activities. So also start experiencing more rainfall rather than the snowfall. So, so the extreme precipitation events, the storms have higher magnitudes, maybe even increase in frequency. So we're experiencing more cold fronts and then the prolonged drought condition. So what does it all mean to the landscape we live in? So there is more runoff. So runoff means more erosion. More erosion means that the soils are getting saturated with water. More runoff means more saturated with water. So the slopes start failing. So we're experiencing more landslides and landfalls of those kind of phenomena. So stream discharges, how much water is flowing in the streams, are varying depending whether we are in the intense extreme weather condition or in the drought condition. I don't know whether you guys been here in the area in 2022 when we have the massive flood on Brandywine River, where the whole area was flooded. This is the image of Art Museum, Brandywine Art Museum, which was completely under the water. And so they just came out with the Brandywine flood study this year. So very interesting document, which addresses, this unprecedented extreme weather event in our area. And so we can go on and on. So that we have more floods, we have more bank erosion in the streams. So it impacts the development of soil. So of course disrupt the vegetation. In the dry areas, there could be a prolonged periods of drought, but then it actually may have a massive outburst of cloudburst or storms, which bring a lot of precipitation to this very dry land, and that will generate the flash floods and debris flows and so on and so forth. And again, so the instability. So this is kind of overall things which you can experience as on, living in the landscape as a result of climate change. So when I was thinking about this talk, so I decided to, looks like, it doesn't matter where you are, in what landscape, whether you're in the area around here or in the desert or in Antarctic. So all of those places are being impacted by climate change. So I decided to pick 3, from my standpoint, most vulnerable to climate change landscapes or environments around the globe, and give you a little bit of a snapshot of what happens there. So I think number 1 probably would be glaciers, right? So if the surface temperature is increasing and we have the areas where the water is being held in the form of the ice, where the area where it used to experience mostly snow precipitation versus the rain precipitation. So these particular landscapes of glaciers are impacted, the most vulnerable. And so there is a report going all around the world that basically all of the world glaciers are melting or receding, or they are showing an unusual dynamic, for example, such as Antarctica. Antarctic ice sheet is so large that there are very complex impact of climate change on the whole entire glacier. So what is documented that it became more dynamic one way or the other than it used to be in the past. So there are areas of permafrost in the polar regions where the waters, the soil moisture remains in the frozen state year-round, and only seasonally the surface part of that melts, but remains frozen in the lower ground. And so this permafrost is melting. So you might be wondering, going back to this graph, so what about methane? Okay, so carbon dioxide in the atmosphere. So there are various sources of carbon dioxide. So, but what about methane? So actually this permafrost, those frozen soils contain a huge amount of methane. And so now they are releasing this methane back into the atmosphere. So yes, glaciers are receding. And so this particular one, which I show here on this image, is the glacier in Iceland. And I took students to Iceland this past summer, and we visited this glacier. And so what is special about it, it is receding just like any other glaciers in Iceland or pretty much around the world. So this glacier was adopted by elementary school students in Iceland. And every year, so a class of elementary students go to this glacier and put the mark where the edge of this glacier is at the current year. And so they kind of build this record of observation of the position of the ice. And it is receding, and it is receding really, really, really fast. Another landscape, which again, I claim to be very, very vulnerable to climate change, is our coastline, right? So as the glacier is melting, where does this water go? The water goes into the ocean. And as a result, the sea level is rising. And so this is the record of the most recent tide gauge data, meaning that the tides are the stations are recording high and low, high and low, high and low tide every day. And when you average that record, so yet again, so you see exactly the same trend. So what does that mean to us? So of course we experience more inundation along the coastline. So it's been observed that the frequency and severity of the storms, which yet driven by a different mechanism, but they are getting more frequent and more, the magnitude are increasing. And then these coastal storms are coming to our coastlines more often and cause a lot of destruction. Well, basically changing our coastal landscape. And then another environment, which again, I choose to focus on, which is exceptionally vulnerable to climate change, deserts or dry lands. So the increase or, well, the weather pattern changes, which we're experiencing as a result of climate change. It's not only drying, but it's actually brings some exceptionally strong storms. So it goes in two ways. So we have prolonged droughts, we have the loss of soil moisture, we have the vegetation drying out, we have the expansion of the desert, which is called desertification. So maybe the lands which used to be suitable for agricultural activity are not anymore. But then on the other hand, so there actually can be intense rainfalls. And so those intense rainfalls in the drylands are also exceptionally dangerous because they trigger the flash floods, episodic flash floods, and debris flows, washing all of the weathered material on the slopes of the canyon and instantly moving them out and causing unbelievable damage to the communities which might be living there. So actually, the drying aspect of the desert generates a lot of dust particles, so fine grained material, which be ready sitting at the surface and can be mobilized to generate the dust storms. All right, so these are the three major environments which I kind of outline, and maybe so there is a little bit more words on this slide where you want to know, understand. So, but again, so this is from my geomorphology class where we kind of brainstorm it. So I'm going to take you around the world and show you some of those particular environments. Alps. So that's where a lot of glacial terminology coming from. So Alps, in the Central Europe, they are known, so high elevated mountains, so they are known for their beautiful glaciers. And it's interesting that from the 16th to the 19th century, so those glaciers actually were advancing. So they were descending down the valleys, and because the climate actually was more cold. So this cold period of climate in those middle age years in Europe is known as Little Ice Age. So again, so they were constantly advancing. And then it was noted that around 1950, so that's again, so the temperature mark, which is very important. So the alpine glaciers begin to melt or begin to retreat. However, our temperature record does not show any significant warming of the average temperature. So what was going on? Why did the ice start melting and receding while the temperatures are still maintained to be kind of overall normal? So apparently it is an industrial revolution in Europe, which was blamed for that, so that the scientists believed that the release of black carbon from the factories pulled up by the wind into the atmosphere and precipitated on the white surface of the glaciers and snow in the Alps changed so-called albedos, changed how the ice was reflecting the solar radiation. So the white and glassy surface, like ice, reflect most of the solar radiation back into the atmosphere without absorbing it. Black material, and you probably know it from wearing a black t-shirt on a very sunny day, you will get really hot because the black material absorbs the heat. So this black carbon dust from Industrial Revolution so start absorbing this heat, and the glaciers were the first one to respond to that. But that was the beginning. And then a lot of carbon dioxide was released through this industrial activity into the atmosphere, and other mechanisms that are working, causing the global increase of the temperature or global warming. And so then all of the glaciers around the world start responding to that. I only have few examples. So this is one of the glacier in Alaska. It is nowadays considered to be the fast moving glacier in the world. Why does it move so fast? Because it actually losing the ice from its terminus, and that caused the ice to flow further and further. Another glacier in Alaska, not far from Fairbanks. So we do have some remote sensing data which show us the change of the position of the ice, and it been decreasing 0.4, like half meter per year. So maybe that number does not mean anything, but so when you start graphing it, so you see the decreasing, so the ice mass is being lost. Another glacier in Kenali Mountains in Alaska, the same story. So our remote sensing data shows not only the recede of the glacier, but you actually can see how the surface of the glacier lowered down, so losing that mass. So that glacier was monitored in detail by USGS scientists ever since 1966, and so actually show see things are in the red. So this is the loss of mass of the ice. Another one is so-called Piedmont Glacier. So this is an exceptionally large glacier in Alaska, kind of unusual size. So the Piedmont is a flat surface, so it's not only formed up in the mountains, but as it was flowing, ice was flowing to the flat rocky surface, so it spread out and formed so-called ice plateau or Piedmont Glacier. So it has an exceptional size, and so it is receding and melting quite rapidly. And because of its size, so it's been estimated that it is significantly contribute to the sea level rise, just because, so like 0.5% of what we're experiencing in the global sea level rise comes from that one glacier in Alaska. So that's quite significant. So, oops. Do we know what happened? Oh, it's back, but it's not back here on my screen. So moving further, yeah, that's it. This is the one. This is
There you go.
Oh, thank you so much. Okay. All right. So moving further, so Patagonia. So Patagonia is the special area in South America. So alpine glaciers, Piedmont glaciers merging together, forming one of the largest in the world ice fields. So there are two of them, the northern Patagonia ice field and the southern Patagonia ice field. Every single glacier there is receding as we know of it right now. So Patagonia is home to the fastest and the most erosive glacier on the Earth, which basically already lost 60% of its mass and volume ever since 1970s. So this gives you just the example of few of those Patagonian glaciers. So this is Uppsala Glacier from the northern ice field, and this is a famous the Puerto Moreno glacier, which is this fastest moving glacier in the world. So Patagonia is located in Argentina. So those glaciers are descending from the Andes. Andes is the mountain range which stretches all the way from Colombia to the southern tip of South America, and most of these mountain peaks has glaciers because of its high elevation. All of the Andean glaciers are losing its ice in the last 3 decades, and the rate of this melting is unprecedentedly high. It is actually higher than in the Alps or in Alaska, which I just mentioned. So here is again, the scientists put all this data together and show the cumulative mass loss of the ice in the Andes and Patagonia and compare it to European records. So this is a European record, to the Arctic, to the Asian mountains, and to Alaska as well. And so here is Patagonia. And so you can see how, how fast it is decreasing. But so, well, basically in the last decades or so, we don't see any positive trends here at all. All right. So where all this water goes, the water goes into the ocean. And now we are facing the accelerated rate of the sea level rise. So, we do have some proxy record of what the sea level was doing in the past, just like we have the proxy record of climate change. And so it is very tightly correlated together. So basically what the temperature on Earth is doing, so, well, it's very much related to what the sea level is doing. And again, so this is the data which was reconstructed by Svetlana Zherevyeva back in 2008. So it was kind of a breaking through article in Science. She published putting all world tide gauge data together and detrending it and cleaning up the record, and shows that we start experiencing the accelerated sea level rise somewhere around 1850 and on. And so while we do have some fluctuations, high and low, well, however, so we are on the rising trend here. So why is sea level rising? There are actually several contributors to that. One is obvious, right? So the ice is melting and this melt water is moving into the ocean basins. So we actually changed some storage of water on land. Some of our lakes are drying out in the dry areas. So that also has some contribution to the return or take out of the water from the ocean. But as the air temperature is increasing, and I did show you the record consistently for 100 years or so. So on the interface between the ocean surface and the atmosphere, so there is a thermal exchange. So it's not only the atmospheric temperature which is increasing, but the sea surface temperature is follow the same trend. So the top layer in the ocean is warming up. And I'm sure you know these experiments you can do with your refrigerator, freezing water or boiling water for your tea, so that changing the phases of water from boiling to water vapor or from freezing change its volume. So if you warm the water, it expands. So as a matter of fact, so glaciers are important source of the water, but then this water warms up at that surface and it gives even more, because of its expansion, it rises the sea level because of the increase in the volume. And so 75% of these processes are responsible for rising sea level, not only the ice, but. All right, so this, once we have a tide gauge data, which goes back to almost 100 years, some long records, some short records, some disturbed record. But again, so Svetlana Gerevieva did a really, really nice job putting this all thing together and reconstruct it. So ever since 1980s or more going into 1990s, so we have the whole series of satellites orbiting the Earth and measuring the sea surface elevation. So this is called altimetry data. And so altimetry data, so from various satellites, combined together shows you the constant increase. So you don't need to have the tidal gauge record. You can just look at the ocean surface with a satellite and altimetry. And so the trend record, so the global sea level is rising about 3.4 millimeters per year. All right, so what does it mean for us? So there are some other, so here is, I'm going to show a little bit of my own personal research. I study sea level in mid-Atlantic region, and Delaware Bay is in particular area of my study, and I actually was part of the technical report, which was commissioned by the governor of state back in 2018 to give some recommendation for the stakeholders, so what to expect. So we use the probabilistic approach. So we know what the sea level is doing. So we have the instrumental record. We also understand all other natural processes. So we put them all together into the models, into those probabilistic models. And we have a low probability, intermediate, and high probability. And so we predict what the sea level would be doing based on those probability in 2030, 50, 60, all the way to 21,000. 2100. And then we actually projected it onto the Delaware Bay area. And so this work was also done in collaboration with Dr. Hooley, who is the archaeologist here on campus. And so she was very much interested what will happen to different historical sites and archaeological sites. So that's why you see those green dots on this map. But it basically shows you what will happen to the coastline of Delaware Bay in 2030, 2000. It goes on the run. So this is the present. So the next one is well, in 5 years, then 2050, 2080. And 2100. And so when we went through this exercise, what was very interesting to me as a geomorphologist to see, so you know, you live on the coastline, so you're on the cutting edge here, so you are vulnerable to rising sea level, you're vulnerable to storms, you're vulnerable to beach erosion, and so on and so forth. But what this model shows, that the sites which would be inundated first are not necessarily the coastal sites. So that would be the sites are further up the streams, the watersheds. So 10 kilometers away from the coastline would be the areas which will experience more flooding And so more inundation of salt water than along the coastline. So that was kind of an interesting, and so we published that work, which I'm very proud of. Okay, and then on top of that, so we're experiencing hurricanes, right? So we have major storms which build the water. It's called storm surge. So when you have the big storm like Hurricane Sandy, again, I don't know how many of you lived through it, but I did here in this area. So being in Westchester, we experienced again unprecedented amount of precipitation. But on top of this precipitation along the coast of New Jersey, Delaware, Maryland, and further down, and all the way up to New York, so there was a battling waves. And these waves were coming so fast that there was no time for the water to swash back, just like in the normal pattern of the wave activity. Wave go in, wave go out, wave go in, wave splash back. So there were so many waves, and they were so high that they built up this water, which is called storm surge. And unfortunately, it all happened on the highest astronomical tide. So exactly at the time, the landfall of this Hurricane Sandy happened on an hour where the Earth and the Moon and the Sun actually aligned together, and the water surface in the ocean experienced this exceptional gravitational attraction by those bodies. So on top of the high tide, you have those storm surge, and you probably read about the whole devastation of the coastal environments, communities, lost infrastructure, lives, and other massive impact. I'm not going to go into that. So, but with other colleague of mine, so we want to know, okay, so now we know what the sea level will be doing in the future. So this base level for those storm surges will getting higher and higher and higher and higher. So what if the Hurricane Sandy hits the coast of Mid-Atlantic region again? And again, we use the model. I'm not going to go into any detail. It calls the slosh model. And slosh model basically, if you calibrate it in the right way, we calibrated it to this Hurricane Sandy and others, but so I'm going to present this one and see what will happen, how much of the storm surge will rise in the year 230 to 50, 280, and so on and so forth. All right, so this is the graph which shows you what will happen if Hurricane Sandy will hit in 2030, 2050, 2080, and 2100. And what I can tell you that yellow, orange, and red are bad. So this is bad, all right? And it doesn't matter whether you're talking about high, intermediate, or low probability of sea level. So it doesn't matter which, even in 2030, you are already in the red, in the yellow. Another interesting outcome of this exercise was that, again, if you look at the distribution, the spatial distribution of these colors, you have New Jersey and you have Delaware side of the bay. So see how unevenly, so that it seems that the storm surges and the sea level actually would be rising a little bit faster and higher on the New Jersey side than on Delaware side. And that's what the models show us. And again, so we did disseminate these results as widely as possible to prepare the communities and the stakeholders to the future scenarios. And they could be quite different, whether you live in Delaware or whether you live in New Jersey. So that's a little bit of my own research. And so the last type of the environment may be far away from home, but very special places. So these are deserts. Again, remember, the deserts would be another very vulnerable places. And so this is actually snapshots from my student presentation of this Monday, as a matter of fact. So we went around the globe and visited all of the world deserts to see how they're being impacted by the climate change. So these really beautiful images of desertification, how the dry land is encroaching into the agricultural field. So this is what we call expansion of the desert. So this is Gobi Desert, one of the largest and the highest desert in the world. So it's in Mongolia, and so this is the Barhan, massive Barhan dunes, the largest dunes in the world. And so you can see that they are moving over the area where people live. So what else? So it's changed the land use, the dust storms. Again, my husband and I spent some time in Spain. We were fortunate enough during my sabbatical. So we were living in the coast of Spain, right on the Mediterranean Sea, in the winter time. And so this is the dust storm which we experience in February or March or something like that. So this is the dust storm which comes from Sahara Desert into Europe and actually moves all the way into the Alps. And because the people who are skiing in the Alps in the end of February of that year were reporting red snow all over the Alps. So those dust storms become more and more intense. Speaking of the dust storms, what is very important that this Sahara, which produce all this dust, and sand. So this is one of the largest deserts in the world, which is located in northern Africa, is actually a very important and major source of material for soil development. While close enough in Mediterranean area is kind of understandable. Canary Island, yet again, so the area where lots of even dunes, which are blown from Sahara across the oceans, like 1,000 miles away from the coast of Africa. As far as Bermuda, the soils on Bermuda Island are built themselves to grow all these beautiful produce, bananas and pineapples and whatnot, on the dust from Sahara. And it reached as far as Florida. So anyway, so the climate is changing. The Sahara is actually predicted to get greener. So there would be more precipitation in Sahara. And so instead of expanding like many other deserts, it actually will shrink and actually move. And so that will change a lot of global impact of that. California, close to home. So many things impacting California desert, but climate change is one of them. It's already the temperature in the desert, in Mojave Desert in California, increased by 1.5 degrees or 2.7 degrees Fahrenheit, added on the 100 plus numbers, which we usually hear reporting from the Death Valley. So many impact of that. So, but I think one of the very dear to my heart is the endemic of the area Joshua tree. So they are under the threat, and many other ecological systems which are under the threat. And the last one, which I want to show, so very, very, very far away from home, is Australia. And so again, if you think Australia, probably in your mind, lots of deserts. So as Australia, as a matter of fact, has 10 deserts, 10 major deserts. And in opposed to some others, which I showed you, so they actually vegetated deserts. So it has a vegetation and a very diverse ecosystem, animal life and others, creatures which live there. So currently the dunes in most of the Australia deserts are anchored by vegetation. and cemented by minerals. So they are not so much moving. So what they predict, of course, the remobilization of these dunes as the climate will change and dry out, and expansion of the desert, and impact on the Aboriginal communities which live on the edge, and migration of animals, and so on and so forth. All right, in conclusion, we're moving this direction no matter what. So carbon dioxide is one of the reasons of these changes. So this is the predicted global trend of warming. Even if we stop doing what we're doing right now and bring our carbon emission to a zero, we are not going to stop this trend instantly. It will be still going on. So we're living in the changing world. The impact of climate is unarguable. So as I mentioned, even stopping the carbon dioxide emissions, so we will still be warming up because of the inertia of the system. So we're really looking into the adaptation, and here we need a good science. So science is the key thing here, science and education. So in order to solve the societal, environmental, economic problems which climate brings us, and in the conclusion, the snapshot of this moment in United States of America. All of the government sites are down. So speaking of the science, moving forward. So on that note, thank you very much for your attention. I know I didn't really leave much room for questions, but I would be happy to answer if there is any questions.
We will pause for a moment. If some students or others have to get to another class, please feel free to leave quietly. For those of you who do have questions, would you be able to stay?
Absolutely, I am here. Yes.
Good. Okay, so if you have to go, please do, but otherwise, questions?
Please. Yes.
So I think I don't know if I saw it recently or I was seeing that maybe the ozone layer was slightly reclosing. What would be the first, like, if that continues to happen, what would be the first morphologic
It's a very good question. Yes, the ozone hole, as we call it, which formed over Antarctic and has an unprecedented size of it back in 2001 or something like that. So start shrinking, and this is due to the Montreal Protocol. So one of the global community. So this is the success initiative, which brought down the release of, help me out with the name of it, chlorofluorocarbons, right. So what is interesting is that the fact that we have an ozone hole over Antarctica, it actually made it colder. So the climate was really, really, really frigid. So now closing it up, which is a good thing because, again, so it protects us from solar radiation, ultraviolet radiation, is actually probably would be contributing a little bit towards the warming in particular in these particular areas. So there is a hole over the Arctic as well, but not as big as over Antarctic. Well, because the Arctic just does not have those big, massive ice bodies. Yes.
Thank you for your very interesting presentation, and it was actually so much information and so big of a problem that I don't know if I interpreted correctly, but it's not only what the human beings are doing that's causing this. What we're doing might just be, I don't want to say a tip of the iceberg. And of course, what we're doing or not doing could make some changes, but the earth seems to change no matter what we do.
Yes and no. Yes, there are natural mechanisms which drive global climate. And this is some astronomical aspects of the Earth as a planet, the tilt of the Earth, the shape of the orbit, the wandering of the Earth axis. And it happened to be that those astronomical features, they operate on the cycle. Each one of them. There is a 100,000-year cycle for one, for the orbit. So there is a 40,000-year cycle. There is a 20,000-year cycle, plus minus. And it only happened that the climate really started responding to those changes where those cycles kind of overlap or slightly overlap, right? So we do have this cycle change of the climate change because of those astronomical parameters. That's one. So astronomical parameters, as we speak right now, we should be moving into the ice age. So we should be cooling rather than warming. So another aspect of that is what the volcanic activity on Earth doing. So because the volcanoes impact the climate, so they do release carbon dioxide into the atmosphere, so that will warm the climate.
And how much of it comes from the volcanoes rather than, you know?
Exactly.
It seems to be such
It is a very
large-
it's very large project, yeah, a problem.
It has been in existence for millions of years, and what we see, what we talk about is the second of
Correct. But so we did reconstruct those cycles. We reconstruct the rates of the changes. And nowhere in those geologic or climate reconstruction, we see the acceleration of the temperature, which I showed you in the red, of the sea level, which I showed you in red, was observed or recorded or documented. So this is the unprecedented rate, and we're moving in the opposite direction what the normal cycles, climate drivers should bring us into. So based on the volcanic activity, we also should be cooling, because apparently we did not experience anything as dramatic as explosion of Yellowstone, right? Or Tambora eruption back in 1815. So, nothing really happened in the last 100 years of a special, exceptional magnitude, which can impact the climate change for a long run. And so then also what the sun is doing. So the sun has its own activity. So it's called hot spots. And so they, it release more or less radiation and stuff like that. And yet again, so the sun is not as active right now as it could have been in the past. So we should be cooling, but our record shows that we are warming up.
But let me ask you, if we would be cooling, just, it's just a theoretical consideration. So let's say in some millions of years, we would be back in an ice age, meaning then
Thousands of years.
Yes,
Yeah.
the living on Earth would cease too. Do you know what I'm saying? And
Yeah, I
with the
know.
heat, with the heat, okay, so we could only keep life on Earth alive if we're somewhere avoiding these extremes. If we could avoid
Well,
these extremes,
or
right?
some of those extremes actually triggers the adaptation of the of species and animals and human beings, as a matter of fact. So we actually evolved during and spread around the world during the ice age, because we were able to adapt to those very harsh climatic environments, and the change of the landscape as a result of big ice sheets actually allowed the human migration from Africa to other continents, and yeah, very complex. And everything what we do is related to what the climate is doing. Absolutely everything. Yes.
How do you propose telling this information? Because I've had educators tell me that climate change is real. They've had an education, so more than I did at that time. So how and especially in our government currently, I don't think environment is even on the plate, let alone an importance. So how do you put it at the forefront if it's something that's genuinely disappointing?
Well, I think it just starts with the, elementary education. So, you just go back to the educators in school and, they should educate children based on the scientific concepts. Yeah, so lots of outreach programs. So I publicly speak quite often to it, especially right now to the.
They desperately need.
Well, reach out to us, reach out to us. We have the whole group of enthusiastic students who would be happy to come and tell, in a fun way, address those issues and level it to any, level of educator and students.
I have also read a lot of research on what, if you, depending how you present this information, it causes a lot of mental stress on the children. And that is not good either. So you kind of have to balance it out a little bit too, because dealing with a lot of sick people is very ill people is
Yeah.
terrible too. So, instead of, I mean, I don't know the answer to it, but if you only presented, this is terrible and we're all gonna go down the tubes, so to speak, if we continue this, so then we know we're dying, but we know we're dying anyhow. So that's why I wanted to put it in a little larger picture. We're all gonna die. Our ancestors, no, listen,
And-
our ancestors, they have lived 40 years, 50 years. Now we have a high life expectancy of 80 or 90 years. But you know what? If you ever go to the nursing homes where the older people live, and I encourage you to do that, you know what? Then you would say, I don't think that all this medical advancement and keeping these people alive, you wouldn't consider that necessarily a high quality of life either. So I'm trying to say it's relative. It is, it's not, it's this, I don't think you would want to live like that.
Well, yeah, I agree. So just bringing the threat on people and stressing them out is the right
Yes.
way of doing. So that's why I put here adaptation.
Yes,
So,
yes.
and there are lots of different ways how to do that, without stressing the community, stressing the people. But I would definitely, like, as a C-level scientist, I will definitely advise you against buying a waterfront property.
Oh, yes.
Whether I'm threatening you or not, I will just say that out loud, yeah.
Or sell it right away, right?
Or sell it right away.
That's why I don't like to frame it as saving. The plan is gonna be fine.
Absolutely, it's,
Here.
Oh, I see.
absolutely, absolutely.
Right, point is, do you like your way of life?
Mm-hmm, mm-hmm,
And how are we going to adapt? And if you stick your head in the sand,
that's,
right, instead of be one of the, my grandfather was one of 13 children and 5 of them died before the age of 5. That's
Yeah,
what
that's-
medical
yes.
science has done for us.
Yeah.
That rarely happens. I'd like to live in a world where children don't die
mm-hmm,
before the age of 5. So I think we need to know that's a thing. We need
Mhm.
education. And you can make your choices. You can make choices of saying, hey, I want to drive the biggest car and burn coal to heat my house like my grandfather did. And he mined it too. Wonderful, you can do that. But what are the choices you make? And we need to make informed choices, right? So we need to know what's going on and we need to know how to adapt.
Mhm.
And one of those things would be, if you live under seawater on the coast, the sea level on the coast, it may be a difficult place to stay. So it's a matter of choices.
Absolutely, it is a matter of choices, because even after Hurricane Sandy,
Forget.
yeah, no, even after Hurricane Sandy, there were so many cases in those coastal communities where people like, we've been here for years and years, or this house belonged to my grandfather. We rebuilt, we persevere, we will, we will stay here. Maybe it was a time to move to the higher ground, so to speak.
I think the adaptation is a very important aspect, that's most important. But I
highlighted
just have
it.
one more question. We
Mhm.
also have the largest amount of people living on this earth at this point.
That's
And
true.
you know, we haven't talked about that. So maybe also some of the problems are that we have such a huge amount of people. And therefore, it's maybe important that we don't have that many people. If none of us are gonna die anymore. we don't have to-
Oh, that's, we're going into some
Just saying, but you
ethical
know,
issues here, yeah.
We haven't even looked at that.
We
We
did.
haven't looked at that either. The amount
did.
of people are stressing the planet too. It's a fact.
Yeah, have you through the policy?
And it's 7 minutes after 1.
Okay.